I'm Hannah, an engineer on the Flutter team at Google. Given that Flutter is a UI toolkit, you will spend a lot of time creating layouts with widgets. To really understand the code you write in Flutter, it's important to understand Flutter's layout algorithm, which is responsible for setting the size and position of each widget in your app. You can boil the algorithm down to a three-part rule. Constraints go down, sizes go up, and the parent sets the position, starting from the very root of the widget tree and working towards the leaf node. The framework has the same conversation with each widget. A parent widget tells the child widget, I don't know or care what you want to be, but this is how much space is available. And it gives the child a minimum and maximum width, and a minimum and maximum height. For example, a parent might tell its child widget, you can be up to 200 pixels wide and 100 pixels tall. The child widget, now knowing the rules it has to play by, decides its own size. For example, if an image widget is told it can be up to 200 pixels wide, it might check the actual image file and decide it only needs 150 pixels to display correctly. So, it reports back to its parent, I want to be 150 pixels wide. Since the child only wants to take up 150 out of 200 available pixels, the parent must decide where within those 200 pixels the child is positioned, like in the center or aligned to the top left. Some widgets ask you to decide the position, like column, and some have their own rules and default, like center. This entire process happens in a single pass down the tree, making the layout algorithm predictable and efficient. Every widget in the tree has an underlying object that does this heavy lifting of layout and painting, called a RenderBox, which does this negotiation of constraints and sizes. There are a handful of box types that can be categorized by how they prefer to size themselves based on their constraints. Some want to be as large as possible, like center. Some try to take up a specific size, like text or image. And some want to be at the same size as their children, like opacity. And then there are flex boxes, like rows and columns, which are a bit more complicated. These often have multiple children, and they have unbounded constraints on one axis, such as a row's width. The conversation between a row and its children, for example, looks like this. The row tells its children they can be as wide as they want, but must conform to the row's height. It then asks each child, one by one, what size do you want to be? Its children respond with their preferred size, and once it has the sizes for all its children, the row positions them horizontally, one after the other. Understanding this concept makes your life much easier when you are building layouts as your app and widget tree grows. It might also save you some time debugging a common error many new Flutter developers encounter: unbounded width and height errors. So, recall the earlier conversation between the row and its children. The row widget starts by telling its children they can be as wide as they want. Except this time, one of the children responds with, Great, I want to be as wide as possible. But being as big as possible in an unbounded space is infinite. This is the paradox that physics and reason are incapable of handling, much less Flutter. So, that's how you might end up with an unbounded width and height error. Now, you don't need to think about Flutter's layout algorithm all the time, but when you are trying to make a screen look just right, this knowledge will go a long way. So, when you are crafting a beautiful UI in Flutter, you will know exactly what's happening behind the scenes. When in doubt, constraints go down, sizes go up, and the parent sets a position.